Well, let's explore a little further about the transformations of the graphs of reciprocal functions. And we've actually already dealt with horizontal transformations and vertical transformations. We're going to look at those plus a couple of more. And we see here our function model for these transformations, where f of x is equal to a over x minus h plus k, where a and h and k represent real numbers. Now, the a up here, I'm going to deal with this first, can give us a couple of possible transformations. One, if a is less than 0, in other words, if it's a negative number, it is going to reflect the graph, flip the graph, if you will, reflections flips, across the x-axis. And then, so that's a reflection, but it also can create the value of a, or the absolute value of a, can also give us a dilation or a stretching or compressing of the graph. And so here we see that if a is greater than 1, it's going to stretch. If the absolute value of a is greater than 1, it's going to stretch the graph vertically, pull it up, pull it down. And if a is between, absolute value of a is between 0 and 1, but not equal to 0 and 1, it is going to compress the graph vertically. Then, of course, we got our vertical translation. That's the value of k. If k is positive, then it's a vertical shift up. If k is negative, it's going to move it down by that number, and it's going to change the horizontal asymptote. And we've seen that before. Ordinarily, without the transformation of k, if k is equal to 0, then the horizontal asymptote is at f of x or y equals 0. So that transformation, the value of k, if there should be one, is going to give us a vertical shift up or down and change the horizontal asymptote by that value. And then we come to the horizontal translation, and that occurs within the denominator. And so here we got x minus h. And this is where it can get a little bit confusing. If you see what's on this chart here, it says that if h is moves to the right, if h is positive. Well, really, what's really happening, if you think about it, this is x minus positive h, which is going to make that value negative. And that's why it moves it to the right. But if you were just to see, as we see right here, x plus 4 down here in this first example, then that's actually going to move that to the left, okay? It's going to move it to the left, but h is actually positive, isn't it? But in reality, that is x minus negative h. So the way I like to think about it is not the way it's represented here, but if, in this case, and we'll start talking about this transformation right here where I've got x plus 4, that's going to move that vertical asymptote, or we're going to have a horizontal translation to the left. So if it's positive, if I see it's positive, it's really moving it to the left, where here it says it's negative. That's because we got a negative situation, which makes that value positive. And if h is negative, it's going to move it to the right. Now that's kind of the opposite way of thinking, but again, you have to think about what is the format of this, and it's been created by this h minus the value of h. So if we see that in this example where we've got x plus 4, we're going to have a horizontal translation to the left. It's going to move that vertical asymptote from x equals 0 to x equals -4, because we're going to have to set that denominator equal to 0 and then solve it. And so when we do, we see that we're going to have a vertical asymptote at x equals -4. And this plus 1 right here, we'll see that we've got a vertical shift up by 1, which means our horizontal asymptote is going to equal f of x equals 1, or y equals 1. And then lastly, on this particular function, this f of x equals -2 over x plus 4 and then plus 1, that -2 is going to reflect that graph across the x-axis, and it will stretch it vertically because the absolute value of that -2 is greater than 1. So we'll see both a reflection and a dilation. Now I'm going to graph these on the calculator here in a moment, but we're going to go ahead and just quickly look at this second function, g of x equals 1 over 3x minus 1. Now, you could say, well, let's distribute the 3 to the x minus 1, and we would get 3x minus 3. But when I set that equal to 0, 3x minus 3 equals 0, trying to determine where the vertical asymptote is going to be, then I've got 3x equals 3 and x equals 1. And so my vertical asymptote is going to be at x equals 1. And so in a way, I don't really even have to distribute that. I could just deal with what's in that parentheses, the x minus 1, set it equal to 0, and I'll come up with the same thing, that I'm going to have a vertical asymptote or a horizontal translation of positive 1. And then, of course, we're going to have a vertical shift or a vertical translation down by 2. And since our value here is just 1, we're not going to see either a reflection or a dilation, a stretching or compressing. So let's move over to the calculator. I want to show you a couple of things that can become important as you're trying to graph these on your calculator. So we're going to jump over to the calculator and do a little work there. All right, so here we are on the calculator. We're going to graph that first function. If you recall, it was f of x equals -2 over x plus 4 and then plus 1. So I'm going to put in the -2, making sure I hit the negative button and not the subtraction. Hit my division symbol, and then I'm going to put the x plus 4 in parentheses. That's important. Otherwise, your calculator is going to read that as -2 divided by x, and then plus 4, and then plus 1, or actually it'll end up thinking it's plus 5. So there I go. I got -2 over x plus 4 plus 1. And let's take a peek at that graph right quick. All right, so there we go. Well, we can definitely see that our horizontal asymptote has moved, our vertical asymptote has moved to the left. That positive 4, that plus 4, has moved it to the left by 4 units along the x-axis. And our vertical shift of plus 1, we see our horizontal asymptote come in here at plus 1. Now, what we can't really see from this is the reflection and the dilation. So I'm going to enter a couple of other things here. First, I'm going to go in here and graph second. I'm going to change that -2 to just a 2 so that we can see that reflection. So I've got -2 times parentheses x plus 4. Close that parentheses, then we got plus 1. And so this second graph is going to show up in red, and it should let us see how that is reflected. And you can see that the blue then has reflected across the x-axis. Actually, this top blue right here is reflected. Its reflection. Let's look at the piece on the left in blue and the piece on the red in blue. There's our reflection, as well as on the right. That's our reflection. It's reflected across. It's flipped across the x-axis. I'm going to do one other thing. This is a little bit harder to see, but I'm going to change this numerator to 1, to just 1, and that will let us see a little bit of the dilation. It's not going to be really too clear, but I'll tell you what I'm going to do. I'm going to leave it like that. I was just going to erase the second graph. So let's put in the x plus 4, parentheses, plus 1. And let's see, this is going to show up in green. So there my green is with just 1 in the numerator. This is kind of giving me an idea of the dilation where, and let's focus on the blue. Maybe I should have erased the second function where it has stretched it vertically. All right, let's go graph real quick our second function right quick. Another thing that we could do. All right, if you recall, what we had there is we had 1 over 3 times x minus 1. And if I'm going to graph it as I did, I probably better put that in a bracket so it reads that properly. So I'm going to put a bracket, I'm going to hit parentheses, then I'm going to put parentheses, the x plus 1, x minus 1, excuse me, x minus 1, and then the negative 2. And let's see what we got. Okay, we can see here that our what that didn't pick up though. Oh, I didn't close that bracket. That was important. Big mistake. Let me close that bracket because it didn't indicate our vertical translation. Now let's see. I think that's here to get us right. Okay, there we go. All right, well, I can still see that my vertical asymptote is shifted to the right. That negative 1 has shifted it to the right by 1 unit. And my vertical asymptote here has moved it down by 2. Now, just for fun, and while we're here, I'm going to do this and see what happens. What if I just ignored the distributing to 3 and just went in here with parentheses x minus 1. Oh, I forgot to put the parentheses. Parentheses x minus 1. And then negative 2. And we're going to graph it. All right, we see a little bit of a change there because I don't have that. We've got a little bit of a compression. Now, why is that? Why is that? That's because really in my original function, I could think of this as 1/3 times x minus 1 and then negative 2. Now let's graph it like that and see what happens. Because really I see a dilation there. So I'm gonna hit 1 divided by 3. And then I'm gonna say, let me put normal, well I've already done that. Let's do the 3x minus 3. And let's put that in a parentheses. In other words, as if I distributed everything. Now let's close it. And then negative 2. And we see that that green completely overlays the blue, the original function that we did. So in reality, when we see that 1 over the 3 times x minus 1, that's really like 1/3 times the x minus 1 minus 2. And it does give us a dilation, as well as a horizontal transformation, shifting the vertical horizontal shifting the vertical asymptote, and it gives us a vertical translation, which shifts the horizontal asymptote. So those are kind of backwards too, if you think about it. So you just got to kind of get a feel. Always use your calculator. It's your friend that can help you see things if you're coming up on some kind of testing or different exercise that you're working on. All right, well, good luck.